Hello, my name is Gurusaranya Venjamuri. I am from Department of ECE, NIT Andhra Pradesh, and I am here to present for my optimization techniques problem, that is simulated annealing. So first, let us try and understand what annealing basically means. So annealing is a heat treatment process that changes the physical and sometimes also chemical properties. Our aim is that we have to increase the workability of the system. So how do we do this? We do this by choosing random points one by one based on the acceptance probability of that particular point. You can choose random points, and there is acceptance probability function that is also, you can choose whatever probability function you want, but the basic idea is if the next point's acceptance probability is more, then we'll go and go to that point. So the acceptance probability function that is defaultly used or generally used is 1 by 1 plus e power delta by t, where t tells us about the current temperature and delta is basically the difference between the new and old objective function value, giving us the improvement. So this simulated annealing optimization algorithm can be used for minimizing unconstrained and also bound constraint problems. So here if we look at the two graphs, our aim is to reduce the system temperature while finding the minima. So the minima of this function clearly we can see comes at this point. So first we have chosen the first point and then we go to the next. As the system temperature is reducing, even though we are going to a higher value of the objective function, somehow our aim is to, through the iterations, is to arrive at the minimum system temperature possible and also the minimum objective function. This is our final goal. So in MATLAB, how can we do this? That is what we are going to see in this presentation. So the first thing that we have discussed is that we do this in this algorithm is that we choose random points, right? So in this choosing random points, there are two already available functions that we can use, that is fast annealing and Bolt's annealing, which helps in choosing the random trail point. The fast annealing is the default thing that we have seen right now, that is the step length is equal to the current temperature and direction is it's random. And the next kind of function is Bolt's annealing, in which the step length equals to the root of the temperature and the direction is uniformly random. The direction is random in both, but the second one would be more faster because it is equal to the root of the temperature. And the third one would be, you can write your own custom function and use that for random trial point generation. So we have already seen the acceptance probability, and this is the default acceptance probability function. You can also have some other custom function that you can write in a different file and use it for the execution. So what function that we are going to, inbuilt function in MATLAB that we are going to use is SimulatedAnnealing BND function, which has these four values: x function value, exit flag, and the output. So the input arguments would be the initial point, the lower and upper bounds, and the function that we need to minimize. The output arguments that we are going to get would be the solution, like where do we get the minimum, the function value at that minimum, the exit flag, that why did we stop the iterations, and the output information about what we have achieved. So what is exit flag? We have like 6 different values that we can get for exit flag, and each one has different meaning. Like if we get 1 in exit flag, that means that average change in value of objective function is less than the tolerance of the function. If the exit flag is equal to 5, then if the value of objective function is less than the desired value, then we exit and we say that it's not feasible. If the exit flag is 0, then maximum number of function evaluations or iterations have reached. There might be a case where infinite iterations we might be getting, and then we have to exit because too many iterations would just mean that there is an infinite loop and we are stuck in that. So coming out of that would be like, if the memory is full, then we'll come out of that. -1 is when the optimization terminated by an output function or plot function. That is, we have received what we needed. And -2 is that there is no feasible point that we found through the simulated annealing algorithm. And -5 means that the time that we have expected in which the algorithm will complete has exceeded. So what output function has is that like the output has different things like problem type, what is it unconstrained or bound constrained, the iterations, the function count, or number of iterations taken, the message, the reason the algorithm terminated, temperature, total time, and all of that. So what we basically do, it's a very simple thing, that is we store the objective function in different MATLAB file, and we use that in the simulanneal bond function. The trade-offs of this simulated annealing are that we cannot apply this for unbound optimization, and if the number of elements in upper bound or lower bound are not equal, then the initial point warning is issued. Because the lower bound and upper bound are not equal, number of elements are not equal, then we cannot start at a feasible initial point. So now let us try and execute this simulated annealing minimization using MATLAB. We have written a code of basically 7 to 8 lines, and we have written the code of the objective function in a different file. We are calling it into the main file, and this is the main line of the code, which has the simulanneal bound function, which has 4 outputs and 4 inputs. We are trying to minimize a bound constraint problem here. So we have given the lower bound, the upper bound, and also the initial starting point. We are printing 3 things here: how many iterations we have done, what is the how many times we have evaluated the value of the function, and the best value of the function that we have found. So let us try and run this. So this is the output that we are getting, that is the number of iterations is 2465. The number of evaluations that we have done are 2484, and the best function value that we have found is -1.0363, as you can see here. So the optimization termination reason is also mentioned here. We have terminated it because the change in best function value is less than the function tolerance. So that is the reason, and that reason implies to the exit flag being 1. So that also we have gotten here, and this is the x at which we are achieving we have achieved the optimization. This is the x, and this is the upper bound and lower bound that we have given, the function value, the exit flag, everything is mentioned clearly here. So it's a very basic simple problem that we have tried to minimize here. I hope you have gotten a basic understanding about this. And so from this we can arrive at a conclusion that we are able to find the minimum of any unconstrained or bound constraint optimization problem using this simple simulanneal bound function that is available in MATLAB. So thank you.